The process of addition in IBI works very similarly to vertical addition in base 10 or base 2. The core difference is in carrying over. In decimal addition, carrying over occurs when the sum of a column exceeds 9. In binary addition, carrying over only occurs when the sum of a column exceeds 1. But in IBI, carrying over is not quite as straightforward, since imaginary and complex numbers are thrown into the mix. Therefore, instead of reaching a single positive real quota, carrying over occurs whenever the place value exceeds 1 in any direction of the complex plane. Core carrying over rules in IBI are I plus I yields 0 and carries over 1, and 1 plus 1 yields 0 and carries over negative I. Generally, using the negative notation version of the latter rule is preferred, since it can often cancel with another value and make the problem easier. Let's try an example. We'll solve for I1 I0 plus I1 I1. In the units column, 0 plus 1 equals 1. No carrying over is necessary. In the 2i's place column, a carrying over rule applies. I plus I yields 0 and carries over 1. In the negative 4's place column, the 1 plus 1 rule applies, but since we are adding 3 ones, it yields 1 and carries over negative I. In the negative 8i's place column, the negative I cancels with one of the i's, leaving just I. Thus, our final answer is I101. It is already in standard notation, so we can just leave it like that. As a side note, this problem translates to 2 plus 3 equals 5 in decimal. In decimal vertical subtraction, there exists the concept of borrowing, because you can't have a negative digit. But since IBI negative notation allows for that, borrowing is unnecessary. For example, let's solve for I1000 minus I0I0I. In the units column, we have 0 minus I. Remember, we can use negative notation, so we simply get negative I. The 2i's place column is 0 minus 0, which is of course 0. The negative 4's place column is the same as the 1's place. We get negative I. In the negative 8i's place, we have 1 minus 0 equals 1. And in the 16's place, we have I minus I equals 0, which we can disregard since it's a 0 at the front of a number. This leaves us with 1, negative I, 0, negative I. This is a negative notation number, so we have to convert it to standard notation. The 1's place negative I becomes I1I, which cancels with the negative I in the negative 4's place, resulting in 101I. We used a dashed line to show that this is our final SN answer. In decimal, this equation is equivalent to 8i minus 13i is equal to negative 5i. IBI subtraction is generally very simple. The only thing you need to pay attention to is converting from NN to SN at the end. Thank you for watching episode 4 of Imaginary Binary. Stay tuned for more to come.